Okay, so going to the seventh question. A vehicle A starting from rest. Seventh question, do you need to discuss? Ah, okay, you did the seventh question, right? So, 14. Okay, so did you do the seventh one? Ah, okay, great. You hang it out. Okay, we'll see that. How about the seventh question for you? You tried all? No? Okay. Which means we need to discuss that, right? We'll see the seventh question. So, Tharushi, sometimes there are scenarios that, like the fourth question, you have given this individual parameters separately. In that case, you can choose which equation, which formula that we can use. For the first example, let's see. For the fourth one, first question, first part, U is given, V is given, A is given. So T we need to find out what we can use. U given, V given, A given. You can use the second one, right? Yes, good. Uh, and the displacement we need to find out, so you can use this. But again, I have recommended if you can now if you find out the displacement from this equation, you need to substitute the t here, which you have calculated from the previous equation. uh, could be uh, some sort of scenarios that the time that you have taken is kind of got wrong. That happens, right? When we do it sometimes with the calculations, the t that you have obtained will be wrong. In that case, it's better you could just not use this equation, which is involving the time that we have found out. Instead, stick with the data and try your best to get the value that is being asked. For an example, you can use the fourth one here. V is known, U is known, A is given. So S you can find out without having the time. So I'm always recommending try your best to stick only with the data, use only the data to find out the unknown parameter. If not possible, that's totally fine, right? You can use this one. But we are in a kind of like a risk. If you got this answer to be wrong, you're gonna end up with a wrong answer for the displacement. So you're gonna lose both marks, right? Try your best, but it's okay again to be using one of the equation that the previous answer that you have obtained is kind of depending, right? And likewise, in the fourth question, the individual parameters are given, so you can find the unknown very easily. But afterwards, you're gonna see from the fifth question all the way up to the 18th one, it's like a statement question, so we need to extract the data like the way that you have done for the O levels. Right? Sometimes they will give the specific things, and maybe sometimes they are saying there's a land and like 1/3 is given for the wife and the rest of the things are given for the child. Likewise, right? So you need to extract the data from the question and use a equation necessary. Likewise, we will go through the seventh question then. A vehicle A, starting from rest, moves with a constant velocity, constant acceleration of 5 meters per square second. The vehicle B passes at a uniform velocity of. Find the time taken by the A to pass the B and calculate the distance traveled by them. Okay. So always when you start a question, it's better sketch something. So to visualize the scenario, if you just read the question like a statement, you are not kind of like figuring out what's going to happen, right? So always make sure you sketch something and represent the data given. That's what I'm going to do. Get tuned. Question 7. Like that. Mm, there's a vehicle A starting from rest. This guy over the steering wheel, right? And starting from rest means you could mark the initial velocity. What should be the initial velocity here? 0, yes. Started from rest. Okay, maybe I'll just not draw the broad. Moving at a uniform velocity, but sorry, starting from rest, moving the constant acceleration of to this direction. A has an acceleration of 5 meters per square second. Right? So A is just like that, starting the engine and like that starts to go with that acceleration. At the same time, there's this other guy. Right? Wearing spectacles. Right? Moving with a constant velocity of 50 meters per second. Right? That's the idea. So A is just like that going, and meanwhile the B goes right, passing the A. And what can you say about the motion of the A? A is said to be moving with the acceleration while the B is moving with this constant velocity. Tell me, guys, what can be done by this A? Yes, A is moving with an acceleration means its velocity can increase over the time. You can see here, last day I have explained you 5 meters per square second means 5 meters per second in 1 second. That means for each and every 1 second, the velocity will be added by 5. So starting velocity will be 0, but after you like take it to 1 second, 1 second, what could be the velocity? 5 meters per second. And 2 seconds, it has to be 10 meters per second. Likewise, the velocity will be increasing by 5. That's the overall idea of acceleration. Right? You just accelerate, pressing that accelerator, like that, goes faster. So the velocity can increase over the time. Higher the velocities, higher the displacement that we can have, right? And initially, it is going to be having kind of this displacement from here to here because the velocity is increasing from 0 to 5 in the first second. But in the next second, the second, right, it can have a higher displacement because already it is having 5 meters per second velocity and now increasing to 10. Lower the velocity, lower the displacement. Higher the velocity, higher the displacement that we can go, right? And you're gonna see here this guy B is kind of going in a chill, like passing the A like that. But eventually, there will be a movement that this A can, yeah. So there will be a movement. The B will be going like this, right? Maybe with a sad face now. But now the A, he's in a happy face. Uh, should grab the steering wheel like that. Okay, this is A. This is B again. Right. There will be a movement that the A can pass the B. B will be still moving with that 50 meters per second. Tell me, guys, what can you say about the velocity of the A? Once the A is passing the B, should it be the velocity to be 50 meters per second? No. It could be having a different velocity, but the only condition that we can say if the A is passing the B is passing means there's no gap, which means the displacements of both should be equal. That's all we can say. So it's kind of like maybe this and maybe this. Right? So the A and B is like this. So A is starting to move with the acceleration while the B moves. But eventually, it can the A can catch the B somewhere in a forward motion, right? So if the A is passing the B, that means at the moment the A passes the B, the displacement traveled by the A up to there and the displacement traveled by the B up to there has to be equal. So here one is moving with that acceleration while the other one is moving with the constant velocity. So as Thanushi applied last day, we can't apply the relative motion there, right? Relative motion is something else we can learn. You can apply that to here because one moves with the acceleration, the other one moves with the constant velocity. So all you need to do here is find the displacement of the A, find the displacement of the B, or maybe write two equations and make them equal. First thing it is asking, calculate the distance traveled by the A then, which means the SA we need to find out. Or SB and SA are both equal, right? Then for the A, I can apply. Let's try the data first. What are the data that you know? U we know. Initial velocity is 0. What else? Acceleration is known. 5 meters per square second. What else? Time need to find out, right? So we supposed to find out the SA. Oh, we'll take it to be S and that is SA, then that should be find out first. What we can apply out of these three data? Actually no equation that we can use, right? Yeah, let's take the time here to be the t. So here t equals 0 and here t equals t. Right? So we can write even a statement, let the time taken by the A to pass B is equal t. Okay. We're supposed to find both here, right? Okay. So what's the equation you can use? Maybe to this direction, s equals ut plus half at squared. That's the third equation, right? And we have written. And why we are drawing an arrow here? To indicate the direction. More specifically, you are saying to yourself, I have taken to this side positive, which means if something is moving to the other side, the opposite direction, it is negative. And you are saying to the person who is marking your paper also that this guy has taken, okay, to the right side to be positive. That's the overall idea of drawing an arrow because these are vectors. Vectors has both magnitude and direction. Okay. So yeah, I can write SA equals here 0 into t plus half into 5 into t squared. So I'm going to have like SA equals half into 5 into t squared. That's all I could write. We don't know the SA, neither the t. But I can do it for the B. For the B. Right? What's the equation we can use there? We know the initial velocity 50 meters per second. We need to find out the displacement, that is S equals to SB, T equals T. Is it moving with that acceleration? No, it's moving in the constant velocity. So I can put to this direction s equals ut. The first equation can be applied only when something moving with the uniform velocity. So I could write sb is equals to this one 50 into t. And thereafter I can equate the SA and FB, right? And I can get the time first, and maybe thereafter we can find out the SA and FB. We're supposed to find the time and also the displacement at the same time, right? Okay, so maybe in somewhere else you can write when A passes B, I could write SA has to be equal to the SB. So I could write maybe this is 1 and this is 2. So 1 equals 2. So half, this equation you can get. Maybe you can thinking of, we can cancel off 1t. You can do that, right? Like that. You can cancel off 1t. But it's better to have the practice, guys, not to do like that. Let me show you why. Surely you can do that one, right? I'll simplify it like the way, okay, maybe like I can take it like this. Then we're gonna have 5t equals 2 and cross multiplying to the other side, then it becomes 100. So this cancels off and t equals to 20 seconds. So after 20 seconds, this guy can pass, the A can pass the B again, right? But if I just do it this way, usually the maths guys prefer to do like that. And there's a reason for that too. Let me show you. So all I'm going to do here is, without cutting the t's, I can maybe take that 50t to this side. So I'm gonna have it, first I'm gonna multiply it by 2, so it will be easy for me. Then it is equals to 100t, and I'm taking the 100t to this side, so it's become minus 100 into t equals 0, right? Then you can see here the t is common, so I can take the t out. Also there's the 5 common, so I can take the 5t out. Then t minus 20 is there, equals 0. So we're gonna have the product to be 0. So any of you guys doing maths? Actually, are doing maths? Bio. Okay, great. Right. So what if we're gonna have a product to be 0? Let's say we're gonna have a square and a triangle. Give the 0. What's the idea? We're gonna have a certain product to be getting 0. Yes, that means the square has to be equal to 0 or the triangle has to be equal to 0. That's how it has to be, right? Let's say we're gonna have to, I'm gonna take some count example here. Let's say 5 into another one next to be 0. So definitely this has to be 0. Or maybe like this into 2 equals 0. Then definitely this has to be 0. Or maybe it could be 0 when both are 0, right? Likewise, we can say here we can have a product, this phi t with this entire thing with the bracket to be 0. So I could write phi t equals 0 or the other thing, t minus 20 has to be equal to 0. Which means I could divide this 0 by 5. So t equals 0 or t equals to 20 seconds. So we can have two solutions here. We can say it to be solutions, right? Usually we are doing it by simplifying quadratic equations. This is a quadratic equation with the time. Like the similar way we have taken it for like x squared minus maybe 5x squared minus 100x equals 0. So you should find the roots of x there. Yeah, okay. So what could be the valid solution here? Is it this or this? Well, when you find the time and you take it to be minus, මොකක් value එකක් minus කියලා આવුත් අපි හිතමු මේක minus වුණා කියලා. For an example, this is not getting minus. Let's say this was t plus 20 and 10 to the other side, so it's become minus 20. ඒක වෙන්න පුළුවන්. Time is minus means you have gone for the past, right? Unless you have a time machine, maybe that Peabody and Sherman's one, right? Uh, you can't go for a negative time. In that case, you can just remove out this solution because it's not feasible at all. But here we have get with the positive value that 20, which means this solution is also valid. What can I say about this one? It's also valid. Why? Because we have taken let the time taken by the A to pass the B is t, no? The way that the thing we have done here is the making the displacements to be equal. You're gonna see at t equals 0, both of them are having a 0 displacement. And there's another moment that they're gonna meet at here, which is t equals that 20 that we have found out. So if you just cancel off that t here, guys, you are getting just one solution that the situation could happen. In this question, it is totally fine. මේ question එකට සම්පූර්ණම අවුලක් නැහැ. T equals 20 ගත්ත නම් ඇති මෙහෙම you don't need to simplify this quadratic equation at all. But maybe in a future ones, you're supposed to find out both roots. So, and they are sometimes asking, let me show you one. Not in this one, but a question that we are going to do maybe like a today's homework after we discuss about the next part, the motion and the gravity. Just come to the page 4, guys. I'm just giving a clue for that question. Page 4, see the question 24. Page 4, 24, rhyming, right? And there you're going to see two branches of a tree are at 10 meters and 25 meters above the ground. A child at the lower branch pluck a fruit and throw up to the child at the upper branch with the velocity of 30 meters per second. Show that the child at the upper branch gets two chances, which means we need to show that there are two solutions for the time, right? Likewise, guys, it's better you could just go with like that, unless if you are pretty sure that the t is 0 can be neglected. So for this question, we'll just write it like this way, right? That's how you do it. Copy down the question. It's due question 7. I think how many pages you need to keep? 10 pages, okay. 10 sides, right? 10 sides, okay. The light balancing today is really tricky. So once after you found the t, you should substitute it to the first equation or to the second equation to find out the displacement. So always have this practice, guys. Extract the data, mark them in the diagram, and thereafter, before you apply this formula also, you can write the data in the side, so you can choose the correct equation to be applied. Next, what's the doubt? 14. Okay. So guys, make sure you finish up the tute. I mean, at least try the questions before the class, right? It's okay to be get it wrong, but at least you should try it. At least you should read the question, draw some sketch, and there has to be a uh, proven way to set, like show me that you have been tried that question, right? Okay, so we'll see the 14th question and we'll move into the next new part, which is the motion under gravity. 14th one soon on the page 3, tute 14 on the page 3. Two trains drive face to face by an accident. Why we say it's by an accident? Yeah, it's not supposed to happen because in these areas we can have a single railway that is going. So always by the stations they're gonna manage the trains. I think you have seen like the trains are being stopping in a certain station until the next train comes, right? Uh, but unfortunately the two trains are going face to face. Train A moves with a velocity of 40 meters per second. Okay, so now it's time for us to draw a train. Did you like find out the SA here? I didn't do that, guys, for the previous one. Maybe by one, you should do that, right? SA equals, you can have half into 5t squared, half into 5 into t squared is 20 squared. So half into 5 into 400, 200. So that is 1000 meters. That's 1 kilometer, right? After 1 kilometer, they can pass the B in the previous question. Okay, so I'm not going to draw that automatically, right? Instead, I'm just going to draw a single couch like this. There's a train A moving with the velocity of. That's how you need to do, right? While you're reading the question, sketch it. 40 meters per second. And the train B moves with the velocity of. Okay, this is B moving with the velocity of 20 meters per second. The train A gives a deceleration of 1 meters per square second, which is a pretty slow value, right? To this side, it is a deceleration. How you mark a deceleration? Deceleration in English also is the opposite of acceleration. So when you mark the acceleration, it is to be minus. Right? To this direction, it's a minus acceleration, so we can say to be a deceleration. Okay, then the train B. Okay, that's what we need to find out, right? What's the deceleration of the B here? I'm gonna take it to be yeah, okay, A B maybe. That has to be minus to this direction, and we're supposed to find that. What's the deceleration of the B to stop the trains before crashing? So A is going to apply the brakes and gives this deceleration once the separation between them is 1 kilometer, so I can mark it to be 1000 meters. No, you are saying that acceleration to the other side. Okay, acceleration is to the other side, but still it has a velocity. So you can see here it's 40 meters per second, and the deceleration is 1 meters per second, which means what? You can have here 1 meters per second in each and every second, and it's a minus. So after this go by 1 second, what should be the velocity? 40 minus 1, 39. Still it goes forward, right? Because there's a forward velocity. Then after another second, 38, 37, 36, 35, like that, stopping. And at the same time, the B should stop too, right? Otherwise, when the A apply the brakes and stop somewhere here, if the B moves continuously, the B is going to crash the stopped A. So they have like identified the accident maybe 1 kilometers ahead, which is 1000 meters. That's what the question says, 1 kilometers. And somehow they need to apply the brakes, meeting them face to face, like that. Just the movement stops, right? So what can you say about the velocity of A here? The final velocity of A then? Yeah, it has to be 0, right? Right? So the final velocity of A has to be 0. The final velocity of the B also has to be 0, right? Maybe VB and VA. Okay, it's just V. Fine. That's for the B. This is for the A. All right. So until the moment the velocity of A becomes 0, let's say it has been moved a distance of SA up to here. And when the velocity of B becomes 0, let's say it is to be the SB from here, right? We can't say that they are kind of stopping in the very middle. We can't say about that. So let me just correct the visualization to be like this maybe. Actually, it has to be the other way, right? It's okay, right? You can just mark it to any direction. I'm just switching to the other side because initially the A has a higher velocity. So I'm supposing that the A has moved forward much than the B. Again, totally fine. You can draw it anywhere. I'm just drawing it to be much realistic here. SB, and this is SA. Okay, great. Uh, VA has to be 0. So VB also has to be equal to 0. These are something that I have put by my hand, so they have to be cancelled off or not involving with the final results, right? Okay. What we should find out? The deceleration of the B. Alright. Somehow we need to relate the motion of the A with the motion of the B, right? මොකක්ද අපිට තියෙන එකම clue එක මේ A ගේ B ගේ motion එක relate කරගෙන. A එයාගේ path එකේ individually යනවා. B එයාගේ motion එක individually perform කරනවා. But there has to be some sort of way to like relate the A and B. එතන එහෙම එකක් තියෙනවා. මෙහෙම ලියන්න පුළුවන් නේද? SA is the displacement of the A once it stops. SB is the displacement of the B once it stopped. So to prevent them from crashing, right? Almost like stopping, just touching. The displacement of the A plus the displacement of the B has to be limited to 1000 meters because initially they're gonna have a separation of 1 kilometer, 1000 meters. So they have to at least go that displacement, the addition of them together. Right, that's the only way we can relate the motion of the A with the B. Okay, great. I'll start from the A. බලන්නකො try එකක් දෙන්න. A ට තියෙන data ටික ලියලා 4A එහෙම කියලා ලියලා. මේ පැත්තෙන් දෙන data ලියන්න. මම දන්නේ. Initial velocity දන්නවා. 40 meters per second. What else? Final velocity is also known, 0. Acceleration also known, that is minus 1 meters per square second. We should relate the displacement, so I can write S equals SA. Tell me, what's the possible formula that we could apply? We know U, A, S things we should find out. Yes, exactly. So I can put to this direction. Now in this exam, in this question, guys, it's really crucial to mark a direction that you have taken positive because the B is moving to the opposite direction, right? So B squared equals U squared plus 2AS. So this is 0 equals 40 squared plus 2 minus 1 into SA. So we're gonna have here 1600 minus 2 SA. I can bring this SA to the other side. That is 2 SA becomes 1600. So SA becomes then 800 meters. This is not the answer that we need to find out, but you can move with the B. For the B, I think now you can quite do this. Yeah, B is moving to this side. We'll first write the data. Initial velocity 20, final velocity 0. Acceleration is the thing you should find out, and that has to be a deceleration. So, okay, you might be wondering, are we supposed to put here minus or plus? If you didn't put the minus there, you're gonna get the acceleration AB to be minus, showing that it's a deceleration. Or else you can, since you know about this one before, right? ඔයාලා කලින්ම දන්නවනේ මේක deceleration එක කියලා. එහෙනම් මෙතන minus දාගන්න පුළුවන්. So your answer will be getting with the plus. මම ඉකින්ද මේකට මෙහෙම දාගන්න. minus එක මම ඕනි කියලා හිතාගෙන දාන්න. නිකන් AB කියලා දාන්න. Right? What else we need to find out? Okay, SB කියලා ලියන්න පුළුවන් නේ. Right. එයාට මොකක්ද දාන්නේ? එයාටත් අර equation එකම දාන්න පුළුවන් නේ. To this direction, it's V squared equals U squared plus 2AS. Once again, this is 0, and this is 20 squared plus 2 AB into SB. And I'm going to take it to this side, minus 2 SB equals 400. Then I can divide by minus 2 here. Equal to minus 200. Right? If I can find out the SB, I can apply to here and get the AB, right? Acceleration of the B, or basically here the deceleration. Well, you can do it from this. Already we know the SA. So by this one, I can put it to be 1 by 1. I can write, okay, this is 800 plus SB equals to 1000. So SB here is going to be 200 meters. 100,000 minus 800. Yeah. Applying it to here, I'm gonna have like AB equals, maybe I'll put it here, 200 minus 200. This and this cancels off, remaining is minus 1. Okay, so AB is also going to be equal to minus 1 meters per square second. So if I put already a minus sign, this becomes plus. So we're going to have the AB to be plus. Ultimately, the B also need to be moving with the deceleration of 1 meters per square second. You might be thinking, oh, it can't be, right? How the both can be having the same deceleration? It can be, guys, because this is moving with a higher velocity, so higher displacement it goes to stop. This moves with a lesser velocity, so lesser displacement it goes. That's how we do it. ඔයාලා මේ question එක හදනකොට මොනවාද ඔයාලට ටිකක් අර අපි දිනන මොකද්ද කියන්නේ උගත් පාඩම් හා ප්‍රතිසංවිධාන කොමිසම කියලා තිබෙන්නේ පහුගිය කාලේ අඬුවේ තිබෙන එක. So what are the lessons that you need to know here? Sketching is the best way to visualize what's going to happen, what's happening, right? If you haven't sketched it, you might be not getting this. That's the way to start a question from a certain unknown one. Actually, I'm also trying this question for the first time. I mean, I have done it for previous years as well, but the questions have been changed a little bit for you guys. Always I'm upgrading the tune when a batch passes. So, but I'm not remembering what are the exact values there. So I am also what doing is reading the question, sketching that, then marking some sort of parameters that we need to put by our hand, and approach it to the final answer. That's how you start it from the scratch, from the level 0, right? Okay, so I just need to discuss two MCQs with you guys. More specifically, the question 7 and question 9. MCQ 7 and MCQ 9. I have to finish this. On the page 15. Have you tried that? I see that the page has flipped too, right? Page 15. Make sure that this is going to be the first time that you are kind of skipping, not doing the question. It's okay to be not getting an answer. Uh, do you know what's the meaning of this? It's called like homework කරේ නැති වුණාම ගහන පොල්ල, right? So this is been used for the previous batch. I mean, 2025 batch, right? The single medium students, they are not much interested with doing homework, so I had to take a hard approach after some time. So don't let that to be happen for your batch too, right? I'm not punishing, by the way, right? Don't worry. But make sure that you are encouraged with the questions. Okay, so seventh question then. Seventh MCQ on the page 15. So Tarushi, you're gonna see that there are 5 choices. Normally for the A levels, we're gonna have 5 choices. For the O levels, we had 4, right? So there's something called average velocity. This is the equation that we can use. I'm just giving a recap. We have learned it last day. So you might be ended up thinking of it's the fourth answer. If so, you are wrong, right? Because v1 plus v2 over 2 is not the average velocity, it's something called the mean velocity. It's just like you just add all the values and divide by the 2 or whatever the number of repetitions. Yeah, yeah, good. It has to be second, oh, the third one, right? Both are seems to be same instead of that 2. You're supposed to find the total displacement divided by the total time. I haven't seen any of your guy has been sketched it. Someone is sketching that, okay. You're supposed to be sketching something. Well, this guy is moving with the velocity va for a certain distance, let's say s. And maybe another distance, the same distance s with the velocity vb, right? So we know that if the velocities changes to cover up the same distance, අපි හිතමු meters 100ක් යන්න කියලා. To cover that 100 meters, if it is going with 10 meters per second, it takes only 10 seconds. If it is going with 20 meters per second, it takes 5 seconds. Which means the time for each and every scenario are going to be different, T1 and T2. So what we should write here, the average velocity, that's the total displacement, which in here s plus s. That's the total displacement it has given. In between, you might be thinking of what's going to happen, like from VA to VB, like is it being accelerating in this movement? Well, we can't say about that because there's no clue with that, right? Divide by T1 plus T2. But unfortunately, though, all these parameters, the S and the T's, are something that I have put by my hand, right? So we need to replace with the givens. The only thing given here is the VA and VB, that's all. But we can say that this is moving within this displacement, it is moving with a constant velocity because there's no clue that it is been accelerating. So for this part, I could write just to this direction, s equals ut, and I can have s equals vat. And to this one, I could write to this direction s equals ut, and that is again the same s but vb into t2. This is t1. Okie dokie. So now I can substitute that to here. All I could do here is I need to cancel off the s, also the t's. So I'm going to replace from this one, right? I can replace here t1 is equals to s over va, t2 is equals to s over vb. Well, I'm gonna have here up 2s and down I'm gonna have t1 plus t2. For the t1 I can put s over va plus for the t2 I can put s over vb. So s's cancels off. That's what we need to happen, right? Because s is also අපි අතින් දාපු ගන්න නේද? s උත් කැපිලා යනවා. Right. So I'm gonna have a weird value here, that's 2 1 over va plus 1 over vb. How you simplify this one even further? 2 1 over 5 plus 1 over 7. I will simplify it. Take the common denominator and you can multiply it up. What's the common denominator here? Well, if you are kind of lazy to find the least common multiple, you can just multiply the both denominators and take a common denominator like that. Right? 5 into 7. So we can have 5 here but not the 7. So 1 into 7 plus. We have 7 here but not the 5. So 1 into 5. So basically just like this. Similar thing I'm going to do in here. 2 over VA, VB. So we have the VA but not the VB, so VB plus. Here we have the VB but not the VA, so VA. Are you okay with that? Great. So this VA, VB can taken up. Then it is going to be 2 VA, VB over VA plus VB. If you are wondering how this came, it is like 2 divided by, this is the big division, VA plus VB over VA, VB. Also you can flip these terms, it's okay because it's the addition, right? 5 plus 7 equals to 7 plus 5. Division එකක් කියන්නේ මොකද්ද? You can put it to be multiplication and take in the reciprocal. That's what I have done here. Okay. So the answer has to be the third one. MCQ එකට මෙච්චර වැඩ කරන්න ඕනද කියලා හිතනව නේද? These are like first 10 questions that you're gonna get for an exam like A levels. And the first 10 questions are supposed to be easy. We'll just skip the 9th question. I mean, I suppose I asked you to do it now, but I think we need to manage the time. I'm letting you to do it as a homework once again, right? Not just that one. You should complete all the question up to 27. Lastly, I told you, right? Just 27 MCQs, guys. And I asked you to do it with like 5 MCQs per day or maybe 3 MCQs per day. If you do it 4 for 6, you can complete 24 MCQs. Maybe 5 then. Just do 5 MCQs per day. But not this week because you're going to have some more MCQs. අර අන්තිම දවසේ රැය කට උඩ වෙනකන් ඉන්න එපා, right? කලින් ටිකක් දවසකට MCQs 5 ගන්නක try කරන්න. And about that, let me tell you a story in the very beginning. Not me, but one of my friends who's from Monaragala. So he came to the Bandar Central, applies there because the A levels English medium wasn't there at that time in that school. So he used to live in the boarding close by. So we also go maybe once a certain class finishes, we are also going for that boarding. And there's a the boarding owners, the son is kind of like yeah, to the rank 28 කොහෙද max වලින් නිරංජන් අයියා කියලා. So we used to go there and do questions with him, right, especially for the maths. So I have seen in his boarding place he has this tube, right? Again, ඔයාලගෙන දැන් මේ tube එක ඕන විදිහට ඔයාලට use කරන්න පුළුවන්, unless you are like giving it for your granddaughters, right, or maybe sons, right? You can just do whatever the things with your tube. So I have seen that he is kind of like having this tube to be clipped down like this and clipped it with a piece of a string. Right? පොඩි clip එකක් ගහලා string එකකින් මේ දොර ගාව එල්ලලා තියෙන්නේ මේ tube එක. එතකොට මේ තව එතනම තියලා තියෙනවා මේ වෙනම තව ලණුවක් දාලා මේ අර නිකන් rough sheets වගේක් තියෙනවා. එතකොට එයා හැමදාම කරන්නේ මේ දැන් අපිත් එහෙම කරා ඒනට මම දොරේ එල්ලලා තිබ්බේ නෑ right. ඔයාලත් එහෙම දොරේ එල්ලන්න ඕනේ නෑ. අර ඒ කියන්නේ එයා දොර අරගෙන රූම් එකට ආපු ගමන් ඇතුළට යන්නේ ක්වෙස්චන් එකක් කරලා ඒක MCQ එක රීඩ් කරනවා. ඒක මෙහෙම ස්මින් කරනවා ගහනවා යනවා. that's all. ඊට ආයෙ ගිහිල්ලා මොන හරි වැඩ කරනවා ආයෙ තේ බොන්න හරි මොකක් හරි බොඩි එක ඇන්ටි නැගිටලා එන්න කිව්වොත් එහෙම ආයෙ නැගිටලා ගිහිල්ලා යන්න කලින් ක්වෙස්චන් එකක් ගහලා යනවා. ඉතින් මම එහෙම දොරේ එල්ලලා තිබ්බේ නෑ. හැබැයි මමත් මේ මේසෙට තිබ්බා ටියුට් එක. හැම වෙලේම මේ ටියුට් එක එහෙම දිග ඇරලා තියෙන වෙන පැත්තක. පේන්න තියෙනවා හැම වෙලේම. තව කොළ ටිකකුත් මෙහෙම දාලා තියෙන දේ. එතකොට අර හැම වෙලේම අපිට තියෙනවනේ අයිසයිට් එක මේ MCQs කරන්න ඕනේ කියලා. එතකොට හිතන්නකෝ නිකන් ඔයාලගේ රූම් එකකින් යන්න එන්නේ දවසකට 5 පාරයිද? නෑනේ 100 පාරක් විතර යනවන්නේ. එතකොට ඔය යන පාරකට සාමාන්‍යයෙන් MCQs එක ගාන ගැහුවා කීයක් විතර ඉවරයි දවසකට? එන ගානක් ඉවරයි නේ. So and also that gives the practice to the time management. I have given you, right? We know what's the big dragon that we are going to fight at the end. දුන්නා නේද paper structure එක මුලින්ම දුන්නා. ඔයාලටත් ඒක පස්සේ දවසක දෙන්න. එහෙම දැනගන්න එපා මොකටද මේ ඉගෙන ගන්න කියලා නේද? paper එක කොහොමද A level paper එකේ එන්නේ කොහොමද කියලා අපි කලින් discuss කරා. So for an MCQ paper we're going to have how many hours? 2 hours. And 50 MCQs are there. And I have shown you how the time management has to be. 2 hours means 120 minutes. Should be divided by 50 because to find out the time taken for a single MCQ. And this is being divided and it's just taking 2.5 minutes. And like MCQ we maximum allocate just 2.5 minutes. That's all. But for your start, you can at least spend 4 minutes. Or maybe like 3 minutes is the sufficient. I mean, safe because 3 minutes, but if you can't do it with 3 minutes, at least try with 4. Right? That time bound will be getting there once you do the questions like that. Because then, අපි හිතමුකෝ දැන් බෝඩින් එකේ ඇන්ටි කියනවා තේ බොන්න එන්න කියලා. අපිට අර දොර ගාව හිටගෙන ඉන්න බෑනේ පැයක් විතර MCQ එකක් නේද? එතකොට මේ යන්න බෑ දැන් අපි වොෂ් එකක් දාලා අඳුන් ටික දාගත්තා දැන් ඉතින් එහාට වැඩ ටිකක් තියෙනවනේ කරන්නේ. එහෙම ඉන්න බෑනේ. ඒක නිසා අර පොඩි ටයිම් එකකින් MCQ කරගන්න අපි encourage කරනවා. right? ඒ නිසා මේකට විතරක් නෙවෙයි කෙමිස්ට්‍රි වලටත් එහෙමයි. බයොලොජි වලටත් එහෙමයි. කෙමිස්ට්‍රි බයොලොජි වලටත් එනවනේ මේ MCQs තියෙනවා. maths කට්ටියට විතරයි MCQs නැත්තේ. So make sure you have the 3 tubes whatever for the other subjects too. Also always been turned like flipped on something like that, right? And play some rough sheets there close by. එතකොට අපිට 8ක් ගාලා MCQs කරන්න පුරු වෙනවා. දැන් ඉඳන් මේ practice එක ගන්න. දැන් යාළුවා නම් ඉන්නේ ඩුබායි වල. එයා මේ survey engineer කෙනෙක්. එහෙනම් තමයි ඉතින්. right? Okay. මේක හරි නේද? right. එහෙනම් අපි අද lesson එකට ඉක්මනට යන් අපි time එක ගත්ත වැඩි discuss කරන්න මේ කලින් questions, but it's okay, right? We need to clear up the doubts. Today we're going to be learning about the second part. You can see in this tube too. This one. That's the motion under gravity. What's motion under gravity? This, right? So if something is being released, we know we are in a gravitational field. So everything here is being attracted towards the earth. And yeah, that's the same reason that there's an apple fallen to the Newton's head, right? Unless a jackfruit. Okay. So yeah, okay. So we are going to learn that motion, how it is working, and what are the parameters related, and how we can find out different unknowns using the same 5 formula that we have already learned. අර කලින් use කරපු formula පහම තමයි use කරන්නේ, but now we are going to apply it for the motion under gravity. So let's try the topic very soon. Motion under gravity. Okay, so we write a very quick note. Also, you know, guys, right? We are not writing very lengthy notes, just the points that we need. Okay, we write the first point then. There's a gravitational field. There's a gravitational field closer to the Earth's surface, or closer to the Earth, closer to the Earth, and this can apply a force. Let me repeat that. There's a gravitational field closer to the Earth, and this can apply a force on any mass, known as its weight, known as its weight. I think you know about that, right? Whenever there's a mass, we can learn about this one for the next part, the force. And the gravitational field is a separate topic. If you can remember, that's the unit 6 that we need to learn, gravitational fields. And there we're going to learn in detail how the gravity works. But for the time being, we know if you have just a mass like this, let's say m, there's a downward force always, which is called its weight. We also guys having a certain weight because we have a mass, right? And the weight will be always applied downwards. Later on we're going to learn this to be the mg. For the time being, we just know that there's a force, right? And that is the weight. Okay, so we try the next point. Regardless of the direction of the motion, regardless of the direction of the motion, the weight acts always downwards. The weight acts always downwards. Which means it's like this, guys. Even though it's moving up or down, or maybe like horizontally moving, weight is always to which direction? Downwards, right? That's the overall idea. Okay, next point, right? The acceleration given by the weight. The acceleration given by the weight for a mass is known as the gravitational acceleration. It's known as the gravitational acceleration. And guys, for the gravitational acceleration, we're gonna use this symbol hereafter. That's just the simple G. Gravitational acceleration, you can put within brackets simple G. And this also, acting vertically down. Acting vertically down. So do you know this value of this G? Yeah. So the actual value has to be very closer to the Earth. Let's say this is very closer, right? Maybe this is that. This is India and this is the Pearl, right? And the other things, right? And this is the Antarctica. I'm just seeing from the South Pole. So if you just stand very closer to the Earth, like this, this size maybe it's a Godzilla, right? So he will experience, not just he, everyone on the closer to the Earth will experience the G to be 9.8, through and so on, some values, meters per square second. That's the actual value for the A levels. And for the easy calculations, we're gonna round off this value to, as you guys said, it is 10 meters per square second. Right. That's the next topic we'll write. Not the topic. Point we'll write. Closer to the Earth's surface. Closer to the Earth's surface. Simple G equals 9.8 meters per square second. And this is called the approximately equal sign here. Equals 10. Approximately equal to 10 meters per square second. Are you guys sure that there's an acceleration here right now? The acceleration due to gravity, are we experiencing that? Well, again, you can confirm that. Just grab something, go to a certain height, and release it. Like that, right? You're gonna see here, at the very moment I'm gonna like release that, what's the velocity? Zero. The initial velocity is zero. But after I'm being released, like this, I can just show it to you with the slow motion like going like that, right? In that case, you're gonna see initially you're gonna have a zero velocity, but after some time when it hits the ground, it's having a certain velocity once it kind of landing to a certain place, right? Initial velocity is zero, but afterwards it's gaining a velocity, which means there has to be a acceleration, right? Acceleration is the one giving a certain velocity, adding a velocity. So this right here is falling down with the acceleration due to gravity. Okay, and there's an acceleration for you, sure guys, right? And it's vertically down unless once you release it, it's going to be going somewhere else. Okay, uh, great. So let's try it in the next point. Let's consider the motion of an object. Let's consider the motion of an object released at a certain height from rest. Released at a certain height from rest. Okay. Well, this is a very tall building, let's say like that, and there's a guy here, kind of releasing a certain mass from rest. Okay, this is the mass. Maybe a ball or whatever, right? So you're gonna see here the initial velocity going to be 0, and we know that this is falling down under gravity, so it is g. That has to be 10 meters per square second. What's the overall idea of 10 meters per square second? Yeah, that's very easy. That's 10 meters per second in each and every 1 second. Which means if let's say the time here is t equals 0, again maybe consider here t equals 0. What if we're gonna have t equals 1? The object supposed to be at here with the velocity of 10 meters per second. Right? Each and every second the velocity is adding by 10 in that case. So it's going to be like this, this, a little bit closer, a little bit closer like that. Okay, perfect. So t equals 2, t equals 3, t equals 4. What are the velocities? 10 meters per second, 20 meters per second, 30, and 40. Like that. Great. So there is this sort of a motion that you could see if something falling down under gravity. Why you're gonna see here, initially we're gonna have smaller gaps, but later on the gap increases. Yeah, it is accelerating. So why? Gaps. Here we're gonna have a higher gap than this. We have considered a time gap 1 second. Yes. Since it is accelerating, the velocity is increasing. It's same as an object moving horizontally. Last day we have considered about it. Higher the velocities, higher the displacement it can go. Smaller the velocities. Here you can see it just increasing from 0 to 10. So the velocity will be fluctuating between 0 and 10. So lesser velocities, lesser displacement it can have with that 1 second gap. But thereafter it's increasing from 10 to 20. So the gap has to increase. Here from 20 to 30. So we're gonna have a huge velocities here. So greater the displacement it can have with the same time gap. එකම 1 second lap එක තමයි අපි හිතලා තියෙන්නේ. But higher the velocities, higher the displacement. That's how the acceleration of that's how an object accelerates, right? Accelerate කරන object එකක අපි displacements represent කරන්නේ ওই විදිහට තමයි. කොහොමද? Right. So we'll draw it. අපි අඳිමු. ඒ වගේම you're supposed to find this S1, S2 and S3. Oh, this is S2, right? This is S1. So how do you find the displacements, guys? S1, S2, S3 and those things. And you can use that 5 formulae. Out of that, I think the fifth one going to be very easy, right? Fifth එක ගොඩක් easy වෙයි because you can find out fifth කියලා කියන්නේ S equals V plus U over 2 into T. You can apply to here. Initial velocity මොකක්ද මෙතන? 0. Final velocity? Final velocity is not the final velocity for the entire motion. We are interested with the first gap. මේ gap එක හිතන්න. Initial 0, final 10 over 2 into T. So the time gap we are going to consider is just 1 second, and which is going to be 5 meters. Similar to that here, 10 plus 20 over 2 into 1, that's 15. And here 20 plus 30 over 2 into T1, that is 25. And S3 right here has to be 30 plus 40 over 2 into T, that's 35 meters. And note here the arrow that I have drawn also increasing. Why? These are vectors, guys, so we need to represent them with an arrow corresponding to its magnitude. Higher the magnitude, lengthier the line that you need to draw. Not that too. Again, the lines may these are like shorter. This is the shortest one. Okay, great. We'll do one example question. Questions ටිකක් කරමු. We write example 1. Find the height. Find the height an object will fall under gravity. Find the height the object will fall under gravity in 5 seconds. 5s in 5 seconds. When released freely. When released freely. To the same question, right? Calculate the final velocity. Calculate the final velocity after 5 seconds. Okay, do it. 5 seconds. Just don't jump into the open sea, right? Start from the show, which means you just write the data, right? And thereafter choose a certain formula. You can sketch it too if you need. Okay, so I'm helping you with this since it is the first example question. So initial velocity, no, I have sketched it too, right? In case we need to know the steps, visualize the scenario. So time is 5 seconds. What else we know? Yes, we haven't given any clue about the acceleration, and that's how the questions will be, guys. If it is falling down under gravity and says like that, even though it is not mentioning about the acceleration, we should take it to be falling under gravity. එහෙනම් gravitational acceleration එක තියෙන මේ questions වල කවදාවත් acceleration එක කියලා දෙන්නේ නැහැ. We supposed to know it, right? A is equal to downwards, that's g, 10 meters per square second. And we supposed to find the s first and thereafter the final velocity. Having these data known, what's the equation that we can put? Initial velocity, time, acceleration, and we need to find the displacement. That involves a velocity, not the displacement. So I can put s equals ut plus half at squared, right? Downwards. Make sure you are applying it downwards. මේ arrow එක අනිවාර්යෙන් තියෙන්න ඕනේ. Downwards, which means you are considering downwards to be positive. That's what it says. You can write with the pencil. I have taken downwards positive. That's what it says, right? Not with the words, but just drawing a single arrow. ඔයාලට මෙහෙම pencil එකකින් හරි ලියා ගන්න පුළුවන්. S. Initial velocity 0. Time is 5 plus half into 10 into 5 squared. So that is just 5 into 25. 125. You know it. Right. Then we supposed to find the velocity, right? Final velocity. Then we need to find the v. V find a what's v? To find the v, I can put downwards v equals u plus at. So u is 0 plus g, that is 10 into 5. V is equal to 50 meters per second. Well, it's okay to first find out the velocity, and thereafter maybe you can put v squared equals u squared plus 2a. But remember guys, you are in a risk. This v to find the s has been taken from there, right? පොඩ්ඩක් හරි අරක වැරදුනොත් එහෙම s එකත් වරදිනවා. So make sure you are kind of be independent always with the data. Stick only with the data. That's what the Sherlock Holmes says, right? Stick with the data. Okay, right? Again, okay, you can even do that. මෙහෙම කරන්නත් පුළුවන් අවුලක් නැහැ. Supposing that it's your lucky day. Okay, seems easy, right? We'll move to the second example. A ball which was thrown downwards at 10 meters per second from a top of a building. From a top of a building has reached to a velocity of has reached to a velocity of has reached to a velocity of 70 right, 70 meters per second when it hits the ground. When it hits the ground. First part. Find the height of the building. Find the height of the building. Second part. What is the time taken to reach to the ground? instead of just releasing it from freely, it is being thrown downwards. So we're gonna have the initial velocity here to be 10 meters per second. පටන් ගන්නකොට විසික් කරලා යවලා තියෙන්නේ. And hits the surface with the 70 meters per second. Right. Let's see whether you are kind of confident enough to tell what's the time it has been moved without doing a calculation. Yeah. කිසිම calculation එකක් කරන්න නැතුව අර time එක කියන්න බෑද? මම නිකන් අහන්නේ. අවුලක් නැහැ කියන එක නේද? අවුලක් නැහැ. It has to be 6, right? Why? G, the gravitational acceleration is 10 meters per square second. ඒ කියන්නේ for each and every second it is adding the velocity by 10. පටන් ගත්තේ 10 වලින් නම් ඉවරලා තියෙන්නේ 70 වලින් නම් 60 meters per second add වෙලා නේද? හැම තප්පරයකම 10 ගාන එකතු වුණා නම් තප්පර 6 seconds කියලා තියෙනවා. එහෙම ටක් ගාලා කියන්න පුළුවන් හැකියාවක් තව චුට්ට දවසකින් හරි එන්න ඕනි. Totally okay for now. We'll stick with the equations. Initial velocity 10 meters per second. Final velocity that's 70 meters per second. A is downwards, that's G, 10 meters per square second. What else we know? We're supposed to find the S, right? Yeah. Height of the building. Let me take it to be H. This is the height. Yeah, okay. So yeah, downwards you can put V squared equals U squared plus 2AS. And this is 70 squared equals 10 squared plus 2 into 10 into H. Are we gonna take it to be like 4,900 and here 1,000? That's totally fine to do like that. But let me show you a trick. What is this? Seems familiar, right? The difference of two perfect squares, I could write A plus B, A minus B. Instead of like simplifying with 4,900, okay, totally fine, right? Come on, use some tricks, saves your time. So it's 70 plus 10, 70 minus 10 equals 2 into 10 into H. 80, 60, 2 into 10 H. That cancels off this cancels off with 3, H equals to 24 meters. නැත අවුල නැහැ 4900 අරගෙන ඒකෙන් 1000 නේ 1000 අඩු 100 අඩු කරලා ඉතින් 4800 එනවා ඒක වල 20 වලින් ඩිවයිඩ් කරලා ආන්සර් ගන්න පුළුවන් කොහොමද එකයි අර සිම්ප්ලිෆයි කරන මෙතඩ්ස් ටිකක් ඉතින් හුරු වෙන්න ලේසි අපිට හරි මේක අපි අර මැරතන් එකක් වගේ දුවනවා නම් අවුලක් නැහැ කොහොම හරි ස්ටාර්ට් කරලා කොහොම හරි එන්ඩ් කරන්න නේද අර 100 meter relay එකක් වගේ 100 meter race එකක් වගේ වුණොත් ඉක්මනට රන් කරන්නයි ඕනේ. එතකොට මේ අපිට හිතන්න ඕනේ නැහැ මේක නිකන් හරියට relay එකක් වගේ 100/4 relay එකක් වගේ. ඒ කියන්නේ time management එක තියෙන්නත් ඕනේ, tactics තියෙන්නත් ඕනේ. දෙකම තියෙනවා. හරි කඩාන මෙතන ලියන්න ගියොත් එහෙම paper ඉවරයි but your answer could be wrong if you are doing it in a hurry. If you do it slowly, your answer could be correct. You are finishing the marathon, but not the first one, which means some of the questions will be left to do. Two keys දෙකක් තියෙනවා අපිට මේකට. එකක් තමයි time management, අනිත් එක තමයි getting the answer correctly. You should manage them both. Eventually, you're gonna have that practice with this cute question, and also we're gonna be doing the papers as well, right? And yeah, okay. How about the time? You already know about it, right? Oh, hello, miss. Hari me, mama kiya. Hari miss, okay. Right. So the time taken you can find out downwards. Let's see, v equals u plus 80. So 70 equals 10 plus 10, 10t. 60 equals 10t equals to 6 seconds. You might be wondering, අයියානේ අපි හැම වෙලේම මේ පහළට arrows ගහන්නේ කිසි purpose එකක් නැහැ වගේ හිතනව නේද? Always we know that the motion is downward, so why we are just drawing an arrow? We can see about that the next example question that we are going to discuss, which is after the break. Right? We're going to have a 5 minute break, right? Now it's exactly almost like 11. You can come by 11:05. 7 minutes හම්බෙනවද දැන් අපිට කිව්වොත් 10:58 time එක. හරි. Just go around and come. Have some fresh air. Come back very soon. We're gonna finish by 12:30. And we have a lot to do. So come back very soon. Very good. Okay. Classroom is too bright, but what to do, right? We have to manage the lighting for the camera, and it's pretty hard to manage it with the daylight. Okay. By the way, there's a photography course going on. I'm just putting ad, right? After you finish the A levels, you can. There's a photography association going in this institute, right? Once you finish A levels, you can, if you are like to be a photographer, or maybe like as a hobby, you can join to that class. She's conducted by me actually, right? Okay. Finishing of the ad. Now there are scenarios where we need to consider the motion under gravity, not just something always falling down. Sometimes there are scenarios like this. Oops. Some flashings. Okay. Okay. Not to be throwing that much height. So anyhow, like this, right? So in those cases, we're gonna see the gravity is acting downward, but you're gonna see it's going up and descends back down, right? Why is it so? If I just do it in slow mo again, going like that, comes to rest and falling back down. So when it is going up, you're gonna see there, to go up I need to throw it, or we're gonna say to be project, right? I need to project it upwards like that with a certain initial velocity, otherwise it's not flying unless I have the Merlin's magic, right? So have you watched Merlin? No. Oh. Let's think of the Harry Potter then. So I think you have already watched the Harry Potter, right? So unless I have that magic, it won't fly up, right? I have to throw it up with a certain initial velocity. But you're gonna see at a certain moment goes up and comes to rest, which means its velocity has to be becoming 0. Why is it so? Because the boring gravity here try to always add a velocity downwards. That's what the gravitational acceleration do, right? Always adds a velocity downwards. Let's say this try to go up with a certain velocity. At the same time, the gravity acts a velocity downwards. So the upward velocity is going to decrease and decrease and decrease until it becomes 0, right? And thereafter, now an object is to be like released from rest thereafter. So the gravity is still there downwards, adding the velocity to the downward direction. So it's going to accelerate downward. So you can see here the upward motion is going with a deceleration due to gravity, while the downward motion is going due to the acceleration of the gravity. Okay, we can consider that kind of a thing. We write like this, a note, putting a point, we write. Let's consider an object. Let's consider an object thrown up. Let's consider an object thrown up with a velocity of 50 meters per second. 50, 50, right? 50 meters per second from a horizontal ground. From a horizontal ground. The position and the velocity. The position and the velocity of the object in each second varies as follows. Okay, you're gonna see here now the gravity is acting down to this direction. G, that is 10 meters per square second. And what can you say about the velocity here then? Projected with 50 or thrown upwards with 50. After 1 second, it's going to be 40. You know the drill, right? 30, 20, 10, and 0. I'll just write it in the other side. Okay. Now what should happen? It can't just go up and fly there, right? Stays flying. You need to drop back down, right? And it will be going like this then. Of course, it's supposed to follow the same path, but to show it clearly, guys, I have just shifted the descending motion to be a little to this side, right? Again, it has to follow the same path. Whatever the path it goes up should be followed back down. To show it clearly, I'm just drawing the descending motion in a adjacent way, right, like this. Maybe to here a little bit. Okay, like that, this. So this part we're gonna have 0 meters per second. This again have 10 meters per second. 20 is falling back down. 30, 40, 50 then. Times t equals 0, 1, t equals 2, t equals 3, t equals 4, this is t equals 5, this is t equals 6. Okay, t equals 10. like that. Great. Now these are the positions of the particles and also the velocities. Right? You can see here reducing gap. Why? Acceleration downwards, motion is to the upwards. So this acceleration right here is going to be a deceleration for the upward motion. So we're going to say that to be ascending motion, right? It's ascending, which means going up. And here is the descending motion. And this same gravity will be acting downwards. I told you, right? Regardless of the direction of the කොයි පැත්තට ගියත් gravity එක තියෙන්නේ downwards. උඩට ගියා කියලා gravity එක upwards එන්නේ නැහැ. Right? So for the downward motion, gravity is also down, motion is also down, so it's an acceleration. We'll draw it. And while you're drawing, you're gonna see some similarities with the ascending and the descending motion. And we are going to consider those properties. You guys are lucky because you are using a ruled book, so make sure you are drawing these at the same levels. If you have some space, guys, just write here this VH max. Okay, finished? Great. So there are properties and we write them. We write in point wise, right? I'll in point again. First point. There's a maximum height. There's a maximum height the particle can reach. There's a maximum height the particle can reach. Within brackets, you can write that be the h max. H max. And the ascending motion. And the ascending motion uh, ascending motion has a deceleration. Has a deceleration and the descending motion. And the descending motion is with the acceleration due to gravity. Okay. Next point, right? At the maximum height. In short, you can write at the h max or at the maximum height. At the h max or at maximum height. The velocity becomes zero instantly. The velocity becomes zero instantly. Which means, guys, here you're gonna see that the object is going up and comes to a certain rest. Zero velocity means it is the object at rest, right? But you're gonna see here, can it be retaining with this zero? මේ zero වලට ඇවිල්ලා එයාට ටිකක් වෙලා ඉන්න පුළුවන්ද පියම් පියම්? එහෙම ඉන්න බෑ නේද? Instant afterward, it is adding a velocity to the downward direction. So at a certain little time, for a snap, the object comes to rest. So we're gonna say this movement to be the instantaneous rest. Right? We'll write to the same point. The particle obtain an instantaneous rest. The particle obtain an instantaneous rest. Next point. Since the time taken to the h max, since the time taken to the h max is 5 seconds. It's 5 seconds. And the time taken to reach back to the ground. Time taken to reach back to the ground is 5 seconds here. Alright, see the board, guys. So you're gonna see here it takes 5 seconds to reach to the top, another 5 seconds to reach back to the ground. So altogether how much? 10 seconds, right? So within this 10 seconds, what's going to happen? like this. Yeah. Is that the ball is touching anywhere? No, right? The ball here, the object here is just flying now at this time. So we're gonna say this 10 seconds to be the time of flight, right? Time of flight means the total time the ball is in the air flying. How far? How much? 5 seconds to the top, another 5 seconds to reach back to the ground. Okay? Uh, 5 seconds to reach back to the ground. The total time, 5 seconds here, the total time the ball is in the air. The object is in the air. We're supposed to know these technical terms, guys. That's why I'm giving. Total time the object is in the air. You can use another color and write within brackets time of flight. Time of flight. Close the bracket, switch the colors, is 10 seconds. 10 seconds. Okay. That's the time of flight. Next one, guys. What can you say about these values? When it's ascending up, it's 40. Descending back, also at the same level, it is 40. Here in this level, 30 and 30. What can you say? 20, 20, 10, 10. They are equal, right? So we can say the velocities are equal. That has a catch. When you say velocity, we need to consider both magnitude and direction, right? Here, magnitude wise, they are equal, 40 and 40, but they are in opposite direction. So, at the same level, at the same horizontal level, the speeds are equal, but the velocities are different. We can say like that. When we say velocity, we need to consider both magnitude and direction. When it comes to speed, just the magnitude, right? Magnitude wise, they are equal at the same horizontal level. Have a horizontal level again. Velocity is different, but speed is equal. Speed can we just consider the magnitude. Okay, we write that. First, we'll write speeds at same horizontal level. Speeds at same horizontal levels. Speeds at the same horizontal level for the ascending and descending motion. For the ascending and descending motion are equal. But since the directions are opposite, velocities are not equal. Velocities are not equal. Okay, guys. Those are the special properties that you're gonna see, right? Great. Uh, Now we'll discuss with this one with a certain example question. To clarify it even further, we write an example question. Example maybe 1 again. A ball is projected up. A ball is projected vertically up. Ball is projected vertically up with a velocity of 70, with a velocity of 70 meters per second from a horizontal ground. From a horizontal ground. We write the first part. මෙහෙම ලියමුකෝ. first part එක ලියන්න කලින් ලියන්න calculate කියලා. ඒක ලේසි. calculate කියලා ලියලා ඊට පස්සේ first part එක ලියමු. Right? First part, time taken to the maximum height. Time taken to the maximum height. Second part, maximum height. Again, displacement again. Second part, parts ගොඩක් තියෙනවා ලියන්න. Right? Third part, no? Sorry, third part. Time of light. Time of light. Fourth part, total distance. Total distance traveled. Last part, time taken for a horizontal level. Time taken for a horizontal level of 120 meters above the ground. Okay, now we'll start. What's the starting point? Sketching. Then marking the data. You are not supposed to draw the all positions, right? එහෙම වෙලා යනවනේ අපිට velocities ඔක්කොම දාන්න ඕනේ නැහැ. You can just mark here u equals 70 meters per second and somewhere the h max and somewhere reaching back ground. It's like that, right? And show the motion. මෙහෙම ගියා වැටුණා. Roughly sketch කරගන්න. This is h max. Then write the data for the considered motion. First one is the මොකක්ද අපි කියන්නේ maximum time taken to the maximum height. So identify where the maximum height. එතනනේ. ඊට පස්සේ අපි A motion එකට data ටික ලියන්නේ. එහෙමයි. What can you say about the velocity here, guys? Yeah, it has to be zero. Good. Now the motions are occurring to two directions. So make sure you are considering the direction properly. Direction where the equation applied. guys, shall we try? Okay, we'll see. And here is the movement that the direction of the application of the formula is going to be very crucial. Uh, so I'm going to consider the ascending motion or the upward motion. So which direction I need to apply the equation then? I can maybe consider upward as positive. So I need to find out the t here, which is the time taken to the maximum height. And I have written the data for that motion. Initial velocity 70, final velocity at the maximum height it is 0. Acceleration due to gravity is downwards 10 meters per second, and time is the thing we should find out. So, what's the equation that we can put? It's better you could put v equals u plus at. To which direction? Upwards, right? Okay. So I'm gonna have your left hand. This is 0. This is 0, and this has to be equals to u, which is 70, plus I am putting the equation upwards, but the acceleration due to gravity is downwards, so that is going to be minus 10 into t. So you can take this minus t to the other side, or I can write here, write with specifically with the steps. 70 minus 100 t, sorry 10t. So 10t goes to the other side, that is equals to 70. So this cancels out. T is equals to 7 seconds. I think I have seen some of you guys have taken it straight away. That's also good, but be careful, right? Because here it is 70, here it is 0. So each and every second the velocity drops by 10 meters per square second. Okay, right. So each and every time the velocity drops, each and every second the velocity drops by 10. So 70, 60, 50, 40, 30, likewise. After 7 seconds, it becomes 0. Or you can write like that. Oh, my left hand is ugly, right? Okay. By the way, guys, I used to write with the left hand when I'm a child. I have childhood, so my mom used to practice my right hand. So I'm just writing with the right hand, but I'm a left-hander, right? All things are doing in the left hand. Uh, I can write with the left hand too, but not nicely. Okay, going to second part. Unnecessary information. Right? Okay, so now second part, the maximum height, right? So you can find out the same data, but we need to find out the s now. S equals to h max. Well, simply I could put upwards v squared equals u squared plus 2as. V squared is 0 squared equals 70 squared plus 2 minus 10. Why minus? I have considered upwards. This arrow indicates that I have taken upwards as positive, but the g here will be downwards. Now you can see why the direction is crucial now, right? This minus doesn't come unless you pick up a certain direction to be positive. These are vectors, guys, so we need to make sure we are substituting both magnitude and the direction. And this is the h max. And yeah, it is minus 20 h max equals 0. I'm writing each and every step, but you can omit them, right? ඔක්කොම steps ලියන්න ඕනේ නැහැ. Practice වුණාට පස්සේ විතරක් steps ටික අඩුවෙන් ලියන්න. I'm just writing it for clearance. So h max right here, 20 h max equals to 4900, and 10 cancels off. So h max equals 490 divided by 2, so it is 245 meters. Note here, I haven't taken the time that I have found out earlier, it is this t. It's okay, මේ t දාන්න පුළුවන්. හදිසියෙ මේක 6 එහෙම කියලා આવුත් එහෙම ඊළඟට තියෙන ඔක්කොම ටික වැරදිලා යනවා. Sticking with the data, but okay, right? I කලින් කියනවා අවුලක් නැහැ, අරක දාන්න පුළුවන්. Then the third one it is asking time of flight. What's the time of flight? මේවා මේ ලියා ගන්න හොඳේ අපිට නිකන් තේරෙන්නේ නැහැ වගේ න I taken upwards positive එහෙම ලියන්න ඕනේ නැහැ එක්සෑම් එකේ හරි arrow එක දැම්මම they knows this minus උනේ කියලා ලියා ගන්න gravity g is downwards I have taken up right? Okay, time of flight. We know that the time taken to the maximum height is 7 seconds. So here I could write time of flight equals twice the time taken for the h max. In this particular example. So that is 2 into 7. That is 14. Right? Is there any other method to get the time of flight? The time of flight එක ඔයාලා හොයාගත්තේ. First we need to find out the time taken for the h max. Right? And thereafter you found it to be twice of it. There's another method that we can use. මේක erase කරා okay කොහොමද මෙහෙමයි Tell me guys if you like project something up or thrown something upward and descends back down to the same level what can you say about the displacement displacement is 0 right it's like this this is your starting position let's say you are starting from home right then going to a shop maybe to buy something and came back home again what's your displacement yeah if you ended up with your friend's house it's going to be somewhere here then the displacement the entire displacement will be the shortest possible distance between the two starting and the ending point here it's going to be this much එහෙමනේ අපි displacement කියන්නේ මෙරිනල් friends ගේ house එක So if he stops there, the displacement will be the shortest possible distance between your house and the friend's house. But if you like came back to your home, starting point and ending point are the same. So there's no displacement. If you reach back to the initial level, initial point, we can say the displacement here is 0. Correct? Okay. Again, මෙතනින් පටන් අරන් okay it's going to the h max and reducing that h max and came to the same point even though I have drawn it to be like මෙහෙම යනවා කියලා අන්දට මේ එකම level එකකින් උඩට ගිහිල්ලා පහළට එන්නේ නේ මෙතෙන්ටම යා reach වෙනවා right okay great then I'm going to do something like this is I could write maybe you could copy it down like alternative method right I'm going to consider for the total motion again from A to C I have marked the points as well from A to C right C කියන්නේ තේම තමයි අතරම A to A තමයි වෙන්න ඕනේ. ඒකෙන් අපි එක දාන්න තුමුකෝ. Okay, great. Okay, for the total motion, I'm going to apply upwards. What is the initial velocity? 70, right? Meters per second. Okay. What's the acceleration? Always downwards. That's the G boring 10 meters per square second. What's the displacement? It will be 0. I can put it upwards 0. Upwards or downwards. There's no displacement, so I can put it to be upwards. Okay. So the t is the t we should find out for the total time where this is t equals 0 and this is t equals t. I'm putting the capital T for the time of flight, which means the entire time taken to go up and come back down. Having these values, I can put something called upwards. S equals ut plus half at squared. So I'm going to have here 0, u that is 70, t minus, why minus? This is downward, okay, I can put maybe plus and minus 10 e squared. So 0 is equal to 70 minus 5t squared. What do you do? Take the 5 out and also 1t. So 5t is given at the 14, right? 14 minus t equals 0. You know the drill afterward, right? It's 5t equals 0. Oh, I can write 14 minus t equals 0. So t equals 0. Oh, like 14 equals t, which is t equals 14, right? Let me just write it the other way. Now tell me, if both solutions are valid or not? Valid the නැද්ද? What is the condition we have taken? To be displacement 0. When time equals 0, at this moment, displacement is 0. Right? Again the displacement becomes 0 at t equals 14. And this is going to be the time of flight. This example, we can do it easily like this method. But there are some scenarios. We don't need to find the h max, time taken for the maximum height, yet it is being directly asked to find the time of flight. So without finding the time taken to the maximum height and multiplying with the 2, you can use this method. Right? It's better you could copy it down as an alternative method. Okay. Copy කරගත්තේ නැද්ද? ඒක. හා, okay. Fifth part එක try කරන්න. හා. Fourth part එක. හා, yes. අර මේ තියෙන අර මෙතඩ්ස් ටිකනේ අර අම්මට සිරගෙන සෙට් වෙනකන් අර ෂෝට් කට්ස් එළිය දාන්න නැතුව වැඩේ කරගෙන යන්න. Afterward, you can do it, right? Once you become masters of it, you can just omit some steps and so on. අර පළවෙනි example question එක නිසා එහෙම පොඩ්ඩක් detail ලියාගන්න. එතකොට හරි. Okay, let's move into the fourth part. Find the maximum. We should find out the distance, total distance. What's the difference between the distance and displacement? Yeah, one is a vector, the other one is a scalar. Distance is a scalar. So, for the distance, we should consider only the magnitude, right? How far it has been moved in a certain path. This is the path, how far it has been moved. From here to here, from A to B, it is 245, and another 245 when it is coming back. So, altogether it's 490. Displacement is 0, reach back to the initial level. Distance will be addition of for the h max, two times the h max. So you can write maybe distance equals 245 plus 245, that's 490. Okay, final part. The time taken for a level 120 meters above the ground. So where the 120 meters has to be? The entire h max is 245, right? So 120 means somewhere below, like this. Then, right. Let's try the data then. Initial velocity is known 70 meters per second. What else? We know the displacement, it has to be 120 upwards. And you know the acceleration, that is boring downwards, 10 meters per square second. We're supposed to find the t. Let me take it to be t, and like this. At here, right? T equals t. Okay. මොකක්ද දාන්න පුළුවන්? displacement එකයි velocity එකයි දෙකම තියෙන upwards නිසා අපි upwards වලටම දාමු s equals ut plus half at squared. That's the only formula I can apply, right? With this data. Do we know the final velocity here? No, right? Then initial velocity is known. Displacement has to be 120. Okay, great. 120 equals 70t minus half 10 t squared. Why minus again, guys? I have considered it to be upwards, but the gravity is downwards. First, I can maybe cancel off 1 0, right? Or maybe equals 70 minus. Oh, like this. Then I can, here you can't just have the other side to be 0. Instead, we need to take all things. Let me take it to be one side. That's 5t squared minus 70t plus 120 has to be equal to 0. So if you have a coefficient in front of the x squared or here in t squared, it's going to be a little bit hard to do. And seeing at these other values, you can see it's divisible by 5. So let me divide it by 5. T squared minus 1 14t plus 25. 4, no? 24 equals 0. Oh, great. Now I have ended up with the quadratic equation. Unlike the other one, we can't just make the one side to be 0 unless we need to write them in product. So we need to find the roots of this. How do you do it? By when? Okay. It's like x squared minus 14x plus 24 equals 0. What do you do? Just multiply it to this. And we need to make 24x squared. Correct? Right. Now we need to make 24. කියන්නකෝ 24 හදන්න පුළුවන් විදි. ලේසිම එක ලියනවා වලින් නේද 24 into 1. 24 නේ. 12 into 2. තව 6 into 4. 8 into 3. ගොඩක් තියෙනවා නේද? Right. So we need to make in the middle the minus 14. දැන් හිතන්න මොකද කරන්න පුළුවන්. Oh, positive 24 තියෙන්නත් ඕනි minus 14 තියෙන්නත් ඕනි. Yes, exactly. You can put it minus 12 and minus 2. Okay. Then yeah, you can put here x squared minus 12x minus 2x plus 24 equals 0. Similar to that, coming to here, t squared minus 12t minus 2t plus 24 equals 0. Now what we do? Couple them and put it to, yeah, okay. So let me couple these two guys and these two, the other two. So I'm going to have here t's taken out, so t minus 12. I should make t minus 12 the other side. And it's minus 2, right? Equals 0. Then put the two that are outside of this bracket, outside of the house, to be a single house. Then I can get the now. This is t minus 12 equals 0. So I'm going to write here after above, you know. So t minus 2 equals 0 or t minus 12 equals 0. So I could write here t equals 2 or t equals 12. So both are valid, right? They are positive answers, so we can't just remove of them. How the two solutions could be valid? Well, you're gonna see here the time we have found is to make this object to be at this 120 meters level. And guys, you're gonna see that this is appearing or this is occurring in two ways. One is in the ascending motion, click like that, and click again, it reached this 120 in the descending motion, and we can say that okay, then t equals 2 is this movement and t equals 12 is the other movement, right? So you're supposed to show that both solutions, the දෙකම solutions දෙකම පෙන්වන්න ඕනේ, එකක් විතරක් පෙන්නලා බෑ. Of course you can't even find that one out, right? මෙහෙම මේක simplify කරනකොට quadratic equation එන හැම අනිවාර්යෙන් you're going to have two solutions. Okay, that's how you do it. So after you get this one, please make sure you write with a certain statement එකක් ලියන්න. The particle pass the 120 meter level. The particle pass the 120 meter level at 2 seconds in ascending motion. At 2 seconds in ascending motion and at 12 seconds in the descending motion. Okay guys, that's how you do it. Okay. So just follow the pattern, and the question asks very similarly, and from this example question I have covered kind of all the parts that we can have for a single question, right? Okay, great. Now it's time for us to come to the tute, and we have ended with the theory of the motion under gravity, right? So kind of level 2 has been unlocked now. This is unlocked, this is previous day. Next day we need to discuss the projectiles. Right. Okay, great. We're going to be coming to the page 4. You can see the questions related to the motion under gravity starting on the page 4. Tute, page 4. We'll mark the homeworks too straight away, right? Since you are in that page. You can do the 19th question. Uh, 20, 21, 22, 23. That's better, I could say, all the way up to question 31. Right. Automatic and 31. Now we are going to try the question 28. Pardon. Wait. 28 අපි පටන් ගත්තොත් 12:30 ඉවර කරගන්න බැරි වෙයි class. 12:30 යන්න ඕනේ නේද හැමෝම? Okay. එහෙනම් අපි essay questions තියලා MCQs පැත්තට එමු. Essay questions ඔක්කොම කරන්න පුළුවන්. MCQs වලට එන්න just come to the page 17. Page 17. Question 32. MCQ 32. Page 17. MCQ 32. Say something about the masses, right? Moves from the same height and from rest. Maybe like this. This is a ink bottle, obviously, right? This is this duster by the hat again, like that. So if you just do it slow mo again, I can just do the slow motion by the camera, but okay, like this, going down, hits the ground. So for any of the equations that we have applied, is there involving a mass? No, right? Regardless of whatever it is, whatever the mass, the gravitational acceleration is constant. ඒ කියන්නේ මේ gravitational acceleration එක g is kind of independent from the mass, even though it's a huge elephant or maybe a tiny ant. The gravity acts the same way, right? Which means for any motion, uh, if it is falling down under gravity, moving the same distance, the each of the mass will get the same velocity, right? ඒ කියන්නේ දෙන්නටම mass දෙකටම හම්බෙන්නේ එකම acceleration එක. If they are getting the same acceleration, and initially they were released from the same height and with the same initial velocity of 0 meters per second, dropped freely. So what should happen for the time taken? Both should take the same time, right? So the answer has to be then 1:1 because the times are equal, right? So we'll write there the gravity is independent. The gravitational acceleration is independent from the mass. Weight take a change, right? Higher the mass, higher the weight, because the mg we are writing there. We write the gravitational acceleration is independent from the mass. Therefore, the time taken should be equal. In that case, hypothetically, then this piece of paper right here and this also should have the same time, but it's not, right? It's supposed to be, right? Theoretically, it has supposed to be, but we know once these pieces are falling down, it surrounding we're going to have the air, right? And that is going to give a certain air drag, we can say like that. So theoretically, if you drop a stone and a feather, those both should land on the same time, but that won't work in the real life in this kind of environment because there's this air drag, which is the air is trying to make it to be flying a little bit, right? If you do it in a vacuum, which means lesser air particles, then that is for sure. I'll share your video, not done by me, but there's another channel, that a scientific channel that I used to always watch the video, something called Veritasium, right? I just share that video, that guy showing a feather and a stone falling down in a vacuum chamber and gets the same time, right? Okay, let's do 34. Yes, guys. Let's take a car with it. First, you do the sketching. I got a sketch kara. V H max. Okay, so it is given the initial velocity is to be the v, right? Don't worry about it. V kila dila is initial velocity. Final velocity is 0, eh? So having the data u equals to v and v equals 0. Okay, no? We'll just directly apply the equation. Like, we know the initial velocity, we know the final velocity, and we need to find out the h max. So v squared equals u squared plus 2as. And this is 0, this is v squared minus 2gs. Why minus? I have applied upwards, gravity works downwards, so it is a deceleration. This is h max. So simply you're gonna have like h max is going to be equals to v squared over 2g. Lazy ne? හිමින් practice කරන්න. එතකොට හරි. Last question we are going to try will be the 47. MCQ 47 on the page 18. තාර්ෂි මේක හරිද? හරිනේ? අද පොඩ්ඩක් නිකන් එහෙනම් නිකන් මොකක්ද ඔයාගේ වෙනවද? කියන්නේ අර අපි අර දැන් මොහොතට පැනලා තින්නේ ෂෝ එකෙන්ම නේ මේ පොඩ්ඩක් මේ මැදට ඇවිල්ලා තියෙනවා. තාම ඩීප් නෑ ඒකින් අවුලක් නෑ නපොඩ්. previous week එකේ අර lesson එක කවුනහම mechanics මේ part එක okay. Before the next class, I'll share you another video to watch. That's about the vectors. ඒ part එක ඕනි next week එකට. ඒ videos දෙකම දාන්න මේ සතිය බලන්න පුළුවන් ඉන්නේ. හා. හෙට එහෙනම් හෙට උදේට yeah morning time එකේ 1 o'clock ට කලින් එනවද මේ පැත්තට? නැත්නම් මම පහුණා නම් අවුලක් නැහැ ටියුට් එක මම තියලා යන්න. මෙතන කාඩ් මාක් කරන අක්කට කිව්වම එයා දෙයි. Yeah. What do you got? catch it. It's dropped freely now, not throwing upwards from a certain height. So this is the displacement. Let's say S1, t equals 0, and this is t equals 2 in the first 2 seconds. And this is t equals 4. So this is the displacement up to t equals 4. So we're supposed to find what? The distance traveled, distance fallen in the first 4 seconds, which is this S2 over the distance traveled in first 2 seconds, that's S1. Yep. We know the initial velocity, that's 0. We know the time. We're supposed to write the displacement. And we know the acceleration. So, downwards, S equals ut plus half at squared. S1 equals 0, 2 plus half 10, 2 squared. S1 equals kilometer 5, 5 into 4, 20 meters. Right. S equals ut median is 0 to 2, median is 0 to 4, plus half at squared. S2 is equal to again 0, initial velocity is 0, 0 to 4 million is 0 to 4 method. This is 4 plus, why plus? I'm considering downward motion, gravity also downwards, so this is 10 into 4 squared. F2 is equals to 5 into 16 t then 18 it's 18 yeah 18. So we're gonna have here to be 20 remain 80 over 20, that is 4. Right. Value එකත් 4 answer එකත් 4 නේ fourth choice එක තමයි එන්නේ. You write it down. Okay, similarly guys, you can try the questions, MCQs, starting from 32 in them, all the way up to, you can have a lot, 62, 32, 62 again, හරියටම 30 MCQs තියෙනවා. Plus the previous one, right? වැඩ ගොඩ ගහ ගන්න එපා එතකොට නේද? I think now you kind of got your bookshelves and all the things are being cleared from the O-level stuffs and preparing for the A-levels, right? So make sure in your study area have a certain sufficient space to put these physics tutes, because you're going to have around 60 tutes until the end of the course, right? So make sure you have space allocated to keep the tutes, right? And don't leave any tute without trying all the questions. Otherwise, things are going to stack up without doing them. Going to be a whole workload coming up, right? So this time, this year was kind of like a charming year, but yet we have to do some night classes as well for the 2025 batch. So I'm being in this institute, like starting the classes at the evening 6, finishing by the morning 6 on the following day. So kind of like 12 hours, and it's been doing that for For the English medium ones, yeah, once a week. And for the single medium ones also once a week. So I'm staying 2 nights in this institute, and there's a mouse here, right, working in the night, and now it seems to be one of my friends because now it's not running by seeing at me, right? සාමාන්‍යයෙන් මම මීයා දුවනවා කටු දැක්ක ගමන්. රැයට ඉන්න මම මීයා කියන දැන් ඌ මට හිතවල. මේ මෙතන ඉන්නේ එහා පැත්තේ, right? ඒ තරම් මම මේ දැන් ඉන්න වෙලා. So I'm just saying that one because a whole wave is coming up, a big wave, right? Not to scare yourselves, but to get yourselves practiced, right? දැන්ම අපි මේ වගේ පොඩි පොඩි questions try කරලා පොඩි නෑ ඉතින් මේවා ටික ලොකුයි නේද? පොඩි පොඩි විදිහට try කරගෙන අපි ඒ ලොකු wave එකකට face කරන්න ලෑස්ති වෙනවනේ steering boards එහෙම අරගෙන නේද? ඒතර ලොකු wave එකක් ආවම ලස්සනට අපිට ඉස්සර යන්න පුළුවන් ඒකට without brain thinking, right? Finally, I'll show you the channel that you can go to see the previous videos, right? මේක මේ අර ඇඩ් එකක් නෙවෙයි ලයික් කරන්න කමෙන්ට් කරන්න කියන්නේ නැහැ හොඳේ. But you can see this one. Let me show it to you here. This is the channel. I'll just share the link. This is the previous video that I have uploaded, and මේ කලින් videos තියෙනවා measurements එහෙම තියෙන එකෙන් videos තියෙනවා. ඒ ටික බලන්න පුළුවන්. මේ ටික විතරක් නෙවෙයි. ඔය ඉතින් video බර ගන්නක් තියෙනවා. මේ කලින් years වල කරපු ඒවා එහෙම ඉතින් අර ඔයාලට කලින් cover කරගන්න පුළුවන්. එහෙම කරන්න ඕනේ නැහැ. අපි ඔක්කොම ටික cover කරනවා කවදා. right? ඒක ඊළඟට මේ අපි අර ක්ලාස් එක නිකන් එනම ස්ට්‍රෙස් වෙන්න දෙන්නෙත් නෑ හොඳේ අපි ටිකක් එක්ස්ට්‍රා කරිකුලර් වැඩ කරනවා ඒ කියන්නේ අපි ෆීල්ඩ් විසිට් යනවා එහෙම දේවලුත් තියෙනවා ඊට පස්සේ අපි බෑච් ට්‍රිප්ස් යනවා I'll just show you one video okay මම එක වීඩියෝ එකක් පෙන්නන අපි අර ගිය පාර බෑච් ට්‍රිප් එක ගියා අද ඔයාලා පෙන්නේ නේද ඒක right මම පෙන්නන එක පෙන්නන එක කට්ටිය මේ බඩු කර තියාගෙන යනවා එහෙනම් ඉතින් කට්ටිය They're going to be played. Maybe. Start here. Down. පොඩි resolution එකකින් play කරන්න මම ඔයාලට පස්සේ මේ වීඩියෝ එකක් දාන්න. අර teaching එකේ දාන්න. අටි බඩු කරලා යනවා.
මෙතන මෙතන.
මාත් යනවා මොකද කරන්නේ?
ඕ මයි හරිද කන්ද ගෑම් බික් කරේ අපි.
ආතල්ද?
අපි මේ අක්ක හැදක තුනල්ලගේ ඉස්කෝලේ කලින් ඉතින්.
අපි හැමෝම සීපොට්
හැම බැජ් එකකම ඉන්නවා බං ගිටාරිස්ට් කෙනෙක් ඉන්නවා චෙෆ් කෙනෙක් ඉන්නවා මම හැම තමයි ඉතින් අපි ඉඩලුත් කරනවා හොඳ ඒකින්ද අර ස්ට්‍රෙස් වෙන්න දෙන්නේ නැහැ ඔයාලා අපි වැඩ ගොඩක් තියෙනවා කරන්න ඉතින් අපි සබ්ජෙක්ට් එකට අදාළ දේවල් සබ්ජෙක්ට් out of subject කියන බෑ ඇත්තටම මේ බැච් ට්‍රිප් එක ගිහිලා ගොඩක් දේවල් තිබ්බා thermal physics වල එහෙම ඉගෙන ගන්න. හරි. ඒක ඇතුලේ මම ඒවත් කියලා දෙනවා. right. practically අපි කොහොමද ඒවා බලන්නේ කියලා. ඒ වගේ ඉතින් අපි හොඳ ගමනක් ඉස්සරහට යන්න. හරි. මම මේ introduction session එකේ කිව්වේ නෑ. මේ කට්ටිය. හරි okay. ඉතින් ඒ විදිහට අපි එහෙනම් වැඩ ටික කරගෙන යන්න and make sure you do all the homework. It's okay you can't do the question. At least you should try it. අර කියනවා නේද මොකද්ද අර යුද්ධයකට එහෙම යනකොට participation එකනේ වැදගත් වෙන්නේ නේද? දුටි කාලා මැරුණත් කවන්නේ participation එක වැදගත්. So that's why just try all the questions. I mean the homework that I have pointed you out. Okay then. Now it's 12:32. You can go home peacefully and we'll see you by the next Monday. Still, I'm trying my best to shift the classes to Saturday evenings, which is I think it's okay for you, right? Yeah, trying my best to shift this class Saturday evening. I'll update you. Once the school started, we're gonna shift it to there, right? All right then. Thank you for joining the class. Have a great week.